Welcome students. In this video, let us look at the slope of a line. We have already understood what inclination of a line is. The inclination of a line is the angle made by the line with the positive direction of x-axis using the standard convention. Now, the slope of the line, usually denoted by m, is defined as tan of the inclination. That is trigonometric tan of the inclination of the line. For example, if you take the first line, let us say that the inclination is 30 degrees. So if the inclination is 30 degrees, the slope of this line is nothing but tan of 30 degrees, which is equal to 1 by root 3. So the slope of this line is 1 by root 3 if the inclination is 30 degrees. So if you take the x-axis, obviously the inclination of x-axis is equal to 0 degrees, right? Because the angle between x-axis and x-axis is 0 degrees. So what is the slope of x-axis? Tan of 0 degrees, which is equal to 0. Now let us say that you have a line which makes an angle of 60 degrees with x-axis. What is the slope of this line? The slope of this line is simply tan of 60 degrees, which is equal to root 3. Now let us go to a y-axis or a line parallel to y-axis. The inclination is nothing but 90 degrees. So the slope is nothing but tan of 90 degrees, which is undefined. That is, the slope of y-axis or vertical lines is not defined. It will be either equal to plus infinity or minus infinity, depending on which neighborhood we approach 90 degrees. So as you can see, the slope starts from 0 for a horizontal line. The value of slope slowly increases. As theta increases, we know that tan theta also increases. So the slope slowly increases, and it increases up to infinity as the inclination reaches 90 degrees. Next, if the inclination is more than 90 degrees, that is, if you go to lines which make obtuse angle with the positive direction of x-axis. So let us say that this angle is equal to 120 degrees. So what is the slope of this line? Slope of this line is tan of 120 degrees. So you have an obtuse angle here. So the value of tan is negative. So the slope is minus root 3. So let us say that the angle now is 150 degrees. So the slope of this line will be equal to tan of 150 degrees, which is equal to minus 1 by root 3. And as the angle slowly increases, it again goes back to 180 degrees and the slope again becomes 0. So effectively, if you look at the values of the slopes, the value of slope starts with 0 for a horizontal line. As the inclination increases slowly, the value of slope goes onto the positive side and it increases indefinitely till it reaches the value infinity at 90 degrees. And suddenly it jumps to minus infinity if the angle is just more than 90 degrees. The value of tan is infinity but on the negative side. So it just jumps on to minus infinity, and as the inclination increases, it slowly falls back to 0 by the time it again becomes horizontal. So the values of slopes goes from minus infinity to plus infinity. So if you take a horizontal line, the value of slope is, if you take a horizontal line, the value of slope is equal to 0. And if you take a vertical line, exactly at 90 degrees, the slope is not defined, but the slope tends to plus or minus infinity. The slope is undefined, But if you look at the limit of the slope, it tends to either plus infinity or minus infinity depending on which side we approach the 90 degrees. And if the angle is obtuse, the slope is negative. Inclination obtuse implies slope is negative, and inclination acute implies slope is positive. Now let us try to further understand the meaning of slope. So now let us try to understand the physical meaning of slope. So what do you mean by slope in general language? So assume that x-axis is a road. So assume that you are walking on this road. If I ask you what the slope of this line is, you say that this is horizontal, there is no slope. You're not moving up, neither are you moving down. So we can say that there is no slope to this line, to this road. The road is perfectly horizontal, hence the slope is equal to 0. Now if the road is somewhat like this, if you are walking on this line, if you are walking on this road, obviously as you move on, you are going up. As you are moving forward, you are moving up. So you say that this line or this road has some slope. You are moving against the slope, right? So here, if you are moving right, that means you are moving towards the positive x-axis. As you are moving right, you are moving up, right? As you are moving right, you are moving up. That is, as you are moving towards the increasing direction of x-axis, the value of y-axis or the value of y-coordinate also increases. So these kinds of slopes are called positive slopes. So what is meant by positive slope? Positive slope means if you move on this line, as x increases, y should also increase. That is the meaning of a positive slope. Or if x decreases, y should also decrease. So this is usually the convention that we follow. So the positive slopes are lines where x and y simultaneously increase or simultaneously decrease. Now if you take the mirror image of this line, something like this, if you take this line, and if you're walking on this line instead, you can see that both these walkings take the same effort. So to walk on this line requires as much effort as to walk on this line. So if you take off the coordinate system, if you don't consider the coordinate system, you can say that the slope of this line is same as the slope of this line. If I'm just talking about slope in general language, I'm not considering the direction. So the slope of this line is exactly same as the slope of this line. But according to the conventional coordinate geometry, on this line, as you move forward, the y-coordinate decreases. That means as the x-coordinate increases, the y-coordinate decreases, right? So such slopes are called negative slopes. So negative slope is the slope of such a line where as x increases, y decreases, or as x decreases, y increases. So these types of lines will have negative slope. Negative slope just means that as x increases, y is falling down. Or if you move in this direction, as x decreases, y is going up. So I hope you understand the difference between positive slope and negative slope. But if the lines are something like mirror images about y-axis, numerically these two slopes will be same. That is, if a line makes an angle theta or 180 minus theta. If a line makes an angle of theta or 180 minus theta, numerically both the slopes will be same. So if this slope is 1 by root 3, this slope will be exactly minus 1 by root 3 if these two are images of one another. So tan theta is magnitude wise same as tan of 180 minus theta. It is these two slopes are exactly numerically same, but one will have a positive sign, the other will have a negative sign. So this is the first thing that you need to understand. Whenever you're given that a line has a positive slope, you have to draw a line like this in this direction. If you're given that the line has a negative slope, you need to draw a line such that it makes obtuse angle with x-axis, right? Next, what is the physical meaning of the number that you have as the slope of the line? So what is the meaning of slope of line? So assume that you have a line like this. Assume that you have a line. So the line is passing through 2 points x1, y1 and x2, y2. There are some 2 points which you know on this line. So what is the physical meaning of the slope of the line? So assume that you are standing here at some point, and after some time you have reached this point. So this is the point x1, y1 on the line. This is the point x2, y2 on this line. So how does the slope relate to the coordinates of these points? So as you know, if you extend this line, it makes some angle theta with x-axis. If you extend this line, it makes some angle theta with x-axis. Now if you draw a horizontal here, as you can see, this theta is exactly same as this theta. And if you draw a vertical line here, such that this angle is 90 degrees. So now, as we have seen, slope is nothing but tan of theta. Slope is nothing but tan of theta. But this theta is same as this theta. So this is a right angle triangle. So tan theta is nothing but this side divided by this side. Right? So what is this side? This side is nothing but the difference between the y coordinates. y2 minus y1. We have seen a similar expression when we derived section formula. So this is y2 minus y1. This is x2 minus x1, right? This distance is y2 minus y1. This distance is x2 minus x1. So what is slope? Is nothing but tan theta is nothing but y2 minus y1 by x2 minus x1. The slope of this line is nothing but the difference in the y coordinates of the 2 points divided by the difference of the x coordinates. This is also a way in which you can find the slope of a line if 2 coordinates on the line are given. And what is the physical meaning of y2 minus y1 by x2 minus x1? So the slope of a line is the rate of change of y with respect to x as we move on this line. So as we move on this line, both the x coordinate changes and the y coordinate changes. So the rate of change in the y coordinate with respect to the change in x coordinate is nothing but the slope of the line. And the slope of the line is a dimensionless quantity. The slope of a line is just a number which denotes the ratio of change in y by change in x. So now, what are the things we have understood about the slope of the line? First, the definition of slope of the line. Next, the range in which the slope varies. Third, what is the meaning of positive slope and negative slope? Fourth, that the slope of allied positions will be numerically same. And fifth, what is the alternate formula by which we can calculate slope? y2 minus y1 by x2 minus x1. Now let us go and solve some questions on this topic.